This, and the other learning resources in this course have been made possible by funding from the European Commission's Erasmus Plus program.
Voila, so I start recording now. It is recording and I will make you host again, Michele.
Yeah, thank you. But remember that you have video number 7 and number 6 that I explained this 2 case study from Bologna, and you have, but okay, if you want to record, no problem, of course. Because today I have zipped in, I have merged the 2 case study in one presentation, so probably it's better to have only one video. Why not? Perfect. So I can.
The floor is yours again. You're the host.
Ah, I am host. Perfect.
Yeah.
So I repeat the sharing. Great. Everybody can see my desktop.
Yeah.
Yeah. Perfect. Yeah. Okay. So welcome again. This is our last meeting about laser scanner case study. This is today I want to speak about two typical case study for underground, because to my friend Cornelius like to match the underground cases and are very close with the archaeological, and so we have chosen the 2 cases. One made it in Bologna. Like Italian, I don't know that in Bologna was this underground river, very, very beautiful, and for me was a new, beautiful discovery. So and the other one was an application in Naples for the company of the water that distribute the water for all the city. They have big problem for maintenance, and the maintenance is very near to the restoration, because in Napoli the deposits of water are very, very old. Probably the first in Italy that was built for the underwater underground water pipelines, so big and so with this important. So it's big interest. So I want to focus my my presentation for 3 important points that we have studied during my previous presentation about the laser scanner workflow. If you remember the vocabulary, and if you remember my target of this presentation, sorry for now, this is in Italian, but it's very easy to translate. It's during a scanning session, it's very important to, before all, the knowledge of the site. Before all, we must know exactly what we want to survey. Second of all, is to define the deliverables. What the customer, or what you, if you are the final customer, what you want to obtain from the survey. In the middle, there is the choice of the software and the hardware. Remember that for our concept, the scanner is not only an hardware, a sensor, but is a solution, hardware plus software. Remember that you must know to push the button to do the scan, and then you must to know the software to post-process the point cloud that is coming from the scanning. So this is very, very important. So the choice of the instrument, the choice of the solution is very, very important, and is defined from from different stuff. For example, in Bologna, our input was only that, Michael, there is a underground river running under the downtown of the city, like in this case. And this is a planimetric view from Google Maps. So it's very easy to plan and to understand the dimension of the site and the accessibility of the site, because this is very important. And here you can see on your left, Piazza San Martino. This is the start point. And with a line, we connect the right Piazza Minghetti, Don Minghetti. And this is the place that was the outside, what the door to go out from the underground river. But we don't know exactly. We know the distance, okay, 50, around 500 meters, okay. The other information that they told to me was a section around 4 meter for 4 meter, so very the thickness was very tight, and there was sometimes on the ground running the water, and in the winter time, or in autumns, of course, the water can be 1 meters high, so can be dangerous to go down. So we must choose the summer times to go down in the river. And very important that the condition of the light was pretty dark. Okay, so this is the input that we have. So the question is what we want to produce, and which is the software and the scanner that we choose. Of course, about this input, the deliverable was only okay, a map, cross section, the typical deliverable that customer asks. So they don't have nothing, no sketch, no preliminary sketch, no project, no planning, nothing, no historical maps, nothing. They don't have no documentation about this site. So they request something, okay? They want to request something to start to create a restoration or a maintenance plan in the future. They must plan money, they must plan financial and material and approaching study, restoration. They want the documentation to start something, okay? So my question was, okay, how many tools and how many solutions I have to disposal to approach this software? And this is okay. If I am a private, of course, I have my sensor, and I use always this, of course. But if I am a company, and I was in Leica before, I was several at my disposal, several tools in terrestrial laser scanners, static laser scanning, mobile laser scanning, everything, backpacks or mobiles or static, everything I can choose. But my solution was to study the alternative. So remember that the company was involved in different system of field of application all around the world. So from forensic, from metrology, from industry, plant, or whatever. And remember that only in the Mediterranean area and several points all around the world are of archaeological interest. And usually in the archaeological and the heritage is a market with a slow, a small money package. So the money, of course, are in a different market, in oil, gas, petroleum, or whatever. Okay, so heritage is not a big part of the interest of the big companies. Like in this case, only in Italy, probably in Greece, probably in both Mediterranean area, okay, North Africa, Turkey, or Spain, or whatever. But if you can believe that the project of the the chapel in Paris that was fired this previous winter was a project of University of Paris that used the Leica scanning, and we have the point cloud of the full cathedral inside and outdoor and indoor. So now today the point cloud of this project was in one night become a very important stuff to do a good planification, a good plan for the reconstruction. So to have a data set stored in a archive and is very important, because today probably is not important, but in the future can be very interesting for all the people all around the world. So it's very important to create a digital copy of the reality, okay? And this is the goal, and this is the target of the big companies that work today with the survey tools, because today every survey tools produce a point cloud. If you think about drone photogrammetry from drone, or laser scanner mounted on drone, or aerial cameras, or laser scanner, terrestrial laser scanner, mobile laser scanner, total station that do the scanner, and backpack that scanning, every tools can produce a point cloud. And this is very important because the point cloud today is a copy of the reality, is a digital copy of the reality. And you must remember that everybody can bring the information and can extract the information from point cloud in exactly what they need about their background. They want to extract dimension for structural, or dimension for archaeological, dimension for architecturals, and so on and so on and so on. Or for probably for fire prevention. Don't open your mind for the possibility for all the people can extract information from point cloud and can produce something. And this is very important to do that. So this is an old photo. I like too much to have this contrast from the modern technology of laser scanner, but the old features and the first instrument and the first tools to bring dimension, to bring information. If you look here, the ear is very a pioneer, no? Unbelievable. So so I asked if was possible, because 500 meter by terrestrial laser scanner was mean at least over 40 scan or 35, 40 scan. So station, no? The different station underground. So my question, and I was, is it possible to use a mobile system to cover the distance of 500 meter? And I discovered that on my basket there was the Pegasus, but this is very big, and of course is not good. This is the backpack. The backpack was a good alternative, because this system is a backpack that mounts on your, and you can walk with the free hand, and you can walk and to scan if you see on the top and on vertical scan, and there are 5 cameras that cover like a full dome to cover the colors, okay? And there is the possibility to put the flash and to set to the flash during the walking, and so the condition of the dark was perfectly okay. Why I have not choose the backpack? Because the noise of the point clouds was too high, because the 2 scan that you see here are running in 25 or 30 meter distance maximum, and the error can be over 1 centimeter. So the noise, remember the noise of the point cloud is the thickness. When you create a cross section of the point cloud, you can see the thickness of the point cloud, and this thickness was around 1 centimeter or 8 millimeter 1 centimeter. It can be a good opportunity if you walk outside, or if you walk in a regular shaping section during your walking, but of course it's not possible to accept this error in a case like this one. And of course the water on the ground create a reflection that is a big part of no data points measured. So I expect a terrible result. And okay, and probably the cost, because if I give you now a number around the cost of this backpack, you can imagine that a private is impossible to buy. Okay. Okay, this is the other one. The next one is a trolley for rail, so it was not perfect for our cases. This is the Pegasus Stream is a solution that can measure merging 2 different solutions, Pegasus outside and 50 georadars antennas can in one step, in one shot, can measure underground and over outside in one step. But this is a solution for roads and for to capture and collect data for a city, for creating the smart cities. If you remember the big project that every company have to create a digital copy of the cities, to create the assets, and to create the collision that the cars can have during the driving without driver. Okay, and this is the project of the next future, not so far future. Okay, a probably solution was the last one. Is a easy funny trolley. Is similar like a supermarket trolley, you know, and it's possible to have a solution off-road with big road wells, and this is a very good solution. The problem is that it's not picking color, okay, it's only geometry, and it's necessary to have or GPS or total station to fix the correct path, because every scanning that moving have the same problem, the same trouble of the drone. When you estimate the position when you by the software you have learned. I have seen Agisoft or I don't remember, Pix4D, I don't remember, probably Agisoft. The software estimated the correct position of the pictures, estimating the path, the correct path of the drone. In the same case, working with the point cloud, the software must have a good path estimation to have the best result on the point cloud. This is the goal of the mobile solution in laser scanning. So I delete everything here. So I've lost my time to show this, and I have choose terrestrial laser scanning. This is the same tools, the same solution in mobile on the field. So you can fix in one slide the application that is possible to do that in very fast solutions. Remember, you can measure by Pegasus, for example, from 20 until 80 kilometers per hour, and you collect terabyte of point cloud. So are unbelievable tools, but was not good for my project, because every tools in this case, except probably the backpack, was too big to go down the stairs, because the stairs was very thick. The thickness was very small, and to arrive on the ground. On the ground was from 8 until 10 meters underground. Okay, so by the stairs was very difficult to approach with a system so big. So I have choose my P40 P series. There was a P30, P40, I don't remember, for several reasons, because is a topographic laser scanner. Topographics, that mean that on board there is remember, this is very important, the vertical sensor is dual axis compensator sensor that guarantee the vertical Z, and to fix the point cloud as vertical. And this is very important too, because on the river, we don't know if we are walking on a flat or in a up and down situation, probably the second one, because if it's the river, the water is running, so the need to have a different quote, a different elevation from start to the end. And then it's very important to have a topographic Z vertical fixed sensors. Okay, this is probably the first reason. This is the benefits of this choice. The worst is the color camera. Color camera of this scanner is too hard, because it's produce 1 gigabyte every picture, and you spend around 7 minutes only to generate the image. And if you think that you can collect point cloud in 1 minute and a half or in 3 minutes, you can believe me, you can accept that is not possible to wait 7 minutes or 10 minutes to generate a spherical image. So I have used an external solution for the cameras. I use it terrestrial laser scanner. I have planned 20 stations every 30 meters. This was the plan, but the finish was 30 stations every 20 meters. Exactly the opposite. External camera for the iStar for interior, for indoor, because the iStar, the cubic image camera iStar have the possibility to fix a picture with around 1911 of HDR. So it's very, very beautiful in dark condition in short range. This is the perfect solution. Short range, because long range you have you lose the pixel resolutions, but in short range. And the range was 4 meters of section of the tunnel, so was perfect, I think. So software, I used Cyclone Register because it was the first version that imported the iStar images in automatic process without do manually point by point, and it was terrible for 30 station. So automatic process is very, very appreciated. And then, okay, Jetstream to have a fast share of the data, because a Jetstream is a free viewer that you can see the point cloud, and you can measure on point cloud by a free viewer, and so very, very, very fast, and work in a streaming. And then I have used 3D Reshaper to create the final deliverable. So cross section, plans, map, 2D extractions through vectorializing and meshing and volume calculation, volume subtraction, everything with 3D Reshaper you can do. Is like probably Cloud Compare plus MeshLab together. Okay, is a full solution software to do a post processing on point cloud. So if you remember my previous training session about reflectivity, this is a part of tunnel, because this is a section, a rounded section, semicircular probably, and it was not so always in this case, because some under the building, the shape of the section was squared, and sometimes was rounded. So was very atypical this project. And if you see on the ground, the black points is the black area where the water was like a mirror effect, and we have loose point during the scan. Okay, but of course was not important, because every point outside the door, outside the water, was perfectly collected. And by reflectivity was possible to find the wet-dry zone. As you remember, the same brick stone here are exactly the same, but change the color. Let's see that in this area, yellow-red area is probably wet, and the cyan yellow-green area, this is dry, probably, because the dry is better reflection, and red one is low reflectivity. If you remember, this is the gradient of color from the lower value red until the blue one is the maximum. And this is one more image about the changing of the section, and how it's complicated under the building of downtown Bologna, because this river running exactly under the main place of Bologna, the historical center of Bologna. So this is very important. And if you see sometimes like some pipe, vertical pipe that is running from the top until the river, and I leave at your imagination what color was this water, okay? was not clean water. Mm? No more words about it. But was very beautiful experience, believe me. Okay, so only to understand how is important the reflectivity value, okay, as to remember. Okay, this is only a shot of a previous slide. You must fix it in your mind. This is the four stuff that influence the reflectivity value, because the reflectivity value influence the precision value, so the rumor of the point cloud. Okay, this is important. I don't spend more words about it, but I like to spend 2 words about the resolution. Resolution in terms of density of points, the density of points of every terrestrial scanner, not only a brand or one brand or another brand. So, today every 3D scan working, rotating in 360 degree in a horizontal and in vertical angle, in vertical direction, okay? So the resolution, so the density of the point is set that you can fix this resolution on the sphere that have origin on the center of the scanner. So if you see here the red part of the sphere is exactly the same, is this resolution probably 1 centimeter, why not? 1 centimeter here and 1 centimeter here. But if you, about this sketch is very easy to understand that this is the wall that you want to measure the resolution, the final resolution on the wall, on the picket surface is the green one, okay? The green one, this green and this green, you can look how is changed in terms of the distance from the sensor, okay? So the typical application of terrestrial laser scanner is to choose the distance of the station the distance of the station not too far from the two times of the diameter. If the diameter is around 4 meters, the distance of the station can be 8 meters, maximum 10 meters. Okay, no more, no more. Okay, this was two parameters of the project. Very important was that were not used targets or topographic point, fixed point on the field, but was used only the cloud-to-cloud method to merge every scan, every position. This was important because in this project was a big challenge to have the same precision with a total station. Okay, this is the first. This is the two pictures during the start session. They are in the first place, and if you remember the top view on Google Map on your left side. And I will start to explain the scanner to the people that host us of the Underground Bologna company. This is the water on the ground, and this is a typical section of the tunnel on the ground, and sometimes there are pipes, vertical pipes that contain the crash of the arcs, because over there are ancient buildings that have problem or static problem. one more. No, this is the snapshot of the at the arrive, at the final of the experience. Okay, this is the box of the external camera of the iStar, and this is the scanner by handle, and this is the tripod of the external adapter that can take the iStar to the same position of the scanner. So the method is to put the yellow tripod on the station to do the scan, to do the 3D scan, and then remove the head, the only scan head, fixing the tripod on the ground, and put the adapter with the iStar in the same position to pick the images. So this is the very, very fast solution, because the scanner only for, I remember you, only for point cloud scanning. Times is 1.5 minutes in low resolution, in the medium resolution, and 3 minutes in high resolution. And for the iStar, is very, very fast to take images in dark condition. You can spend at maximum 1 minute or 1.5 minutes for the full DOM. So it was very, very fast, this solution, and the precision and was very, very impressive. Software during the registration, I have used a solution of the software, an automatic, semi-automatic solution that the software give us, is the Smart Align process, because if you run the automatic process to all the different stations, probably station, for example, 20 and station 10 that are not connected, if you see here, they don't have point in overlap, but probably they can have the same section. And if they have the same section, they can have common point. Why not? Common 3D geometrical region that can be similar, and the software can run the result, can connect the station 10 with the station 20, but they don't have, is not correctly. So using the Smart Align, you can click button here you can create a connection by time, for example, by time, because the scanner during the scan fix the time to start for every station. So the software can align a linear, in this case it was a linear product in automatic process. So in this method, with this method, was not possible to have wrong result. Okay, I have created a top view of the final result. On your left is oriented like the Google Map top view. So on your left you can see the in transparent. In transparent, you can see the outside place and the underground river in transparent method. And if you can see, there are two dots yellow, called 101 and GPS 001. These two dots was picked from the surveyors of Bologna. They have host us, and they invite us to do this experience. They have fixed a point outside, of course, with GPS, and one point with total station. And then we have followed the topographic method by total station called traverse. The traverse is a topographic method to move with high precision the total station in along a path. And then outside at the final place, on your right, of course, they have picked two more points, 1601 and 1602. There are 2 points picked by total station and GPS2, okay? But I have not used this point. I have used only the cloud-cloud overlap, station by station, only laser scanner. Only laser scanner around 30 stations, 35 stations, okay? And I have used the cloud registration. But I have used this point at the, to the hand only to create a comparison of the results. So I have picked the point with the laser scanner, and I have put this point in a software that can estimate the gap, the difference of in terms of distance of this point. And if you can see from number for the point 101 and the 1602, the difference was only 6 millimeters in a distance of 500 meters. So the tolerance was very, very, very small. My result was very, very high precision survey. And this is the verify. And if you see here, error vector is the 3 component X, Y, Z of the full error of 6 millimeter. And if you can see, the full error is in Z. In Z, plus or minus 6 millimeter, that means 1 centimeter and 2. And 1 centimeter and 2 for 500 meters is too high. I cannot accept it. But my challenge was, okay, my point cloud is 3D. Your traverse with total station is 2D and Z. So probably is the total station that's wrong, okay? Because my point cloud was perfect. And if you see in XY, the error in 500 meters is only 1 millimeter. This is an unbelievable result, believe me. It's an unbelievable result. So this is the color component added by iStar. iStar is this small cubic here, is not in scale because this is a solution, an automatic solution called Spheron. Spheron is a more expensive 3D spherical image, but iStar, I preferred iStar, remember, for the short range, okay? Spheron is very beautiful for long range, high definition of color, a lot of level of HDR. It's very, very impressive machine, but very, very expensive, of course. And this is the manual solution, is the adapter of, this is called Nodal Ninja, but in the market, if you search in the internet, there are a lot of adapter, manual and semi-manual, manual adapter for professional cameras. Remember that the target of this adapter is to put the center of the lens that normally for Nikon cameras, Nikon cameras is on the gold line on the lens, and here this line must be aligned with the vertical of the scanner, and the height of this adapter can be must be the same with the laser scanner. Okay, and this is a 2 screenshot of the software that can automatically align the upper line is the color spherical images, and the down line here is the bottom line is the spherical of the point cloud generated in grayscale. Okay, and then you can accept the common pictures. And then you can click after the 30 click, you can click load and software running, and automatic align the spherical images of the picture with the spherical images of the point cloud. Because of course, the center of the two sensors is the same, but the orientation, of course, is not the same, because you cannot put the camera in the same zero-oriented, of course, of the sensor. And so the software asks to you only the common images to have to be sure of the center, of the coordinate of the center, and then automatically by a pixel recognition find the correct orientation of each sphere, each image sphere on the point cloud. And this is a process that can be for 35 station, can be during around 1 hour, 2 hours, 1 hour and a half probably the process, but of course is automatically. And then in the 95% of the cases is fully produce good results. And this is this was a video. I don't know if in this presentation I have copied the movie, but originally, if I click on the PowerPoint presentation, start a fly through video inside the river. But of course, this is only a new shot to remember you that by the software it's possible to measure and to pick 2 points and to ask the distance, and to pick a point to ask the elevation or the XYZ coordinates. And remember that when you have a point cloud on your PC, you have everything, okay? You have the digital copy of the reality, and you can do everything. Everything is possible. What means that it's possible to find the cylinder of the pipe, for example, and it's possible to pick a point on a point cloud of the pipe, and the software estimate the cylinder, and it's possible to extract the diameter or the distance of the cylinder if you want to do an estimation probably of the liquid simulation or whatever. And this is one of the several opportunities that you have of working on a point cloud. Okay. Software. This is 3D Shaper. Today is called Cyclone 3DR. It's possible to create a mesh of the undergrounds. From the mesh, it's possible to automatically estimate the neutral axis. The neutral axis is the red path that you see. That is an estimation from every cross section that software estimate alone, and the middle point, the middle point of the cross section is generating a virtual path. And this virtual path is I have used to create and to generate in automatic process by clicking only on the start point, and to set only probably the step of the cross section. Yes, with the regular step here around 5 meters all over what's mean, and in all the 500 meters. In this case, I have created only a portion of the first probably 25 meters. No, yes, 25 meters. Okay, and so no, 250 meters. Sorry, of course, because are 25 section. And here you can see a 2D layout that you can create in a grid on or whatever. You can export directly in a 2D CAD, or you can export in directly in PDF. Like in this case, using the a grid on the ground, and in the center is always the red line that you have produced before. And you can create a PDF, and you can create a layout, and you can print in a paper directly the final result. For an application close to our interest in heritage, is that the software give us the possibility to envelope the surface when the surface is rounded, not squared, of course. Okay, the possibility is when is always, of course, but have sense when the surface is rounded, and when in 3D is not possible to generate a map of damages, and by the software it's possible to envelope, so to create a flat map with the real measurement, and then it's possible to create a 2D polyline around the damages where the areas are missing material probably, or there is something that we must define, and it's possible to estimate the area of the polyline. In this case, it's possible to create an economic plan to do a correct restoration with the correct measurement, to start, of course, a good plan of maintenance. And this is very important, because if you know the thickness of the missing part of material here, and you know the area, you can estimate the volume of the missing area, and you can estimate how material, and if you know the cost of each material need to fill this missing area, you can create a good plan of restoration. And this is the final top view in overlap with the map of Google. If you see, there is the perfect best fit of facade of the buildings of the left side of the place on your left and on your right, where this part are the trees of the place, and this is exactly how the river running underground the city. This is the main place. This is the historical center. That are the two old towers of Bologna. If you know, you can type on internet. This is a very, very famous place in Bologna, where people in the evening go to stay, because summertime in Bologna is very beautiful. From every student is go out and go there to drink something, and this place is very, very beautiful. But nobody know that under 8 meters there is a current river, because it's exactly a river. And it was a very beautiful discovery for me, and I am very happy to have do it this experience by Laser Scania. Okay, remember that from the point cloud that now I have of this project is possible to extract everything, not only this deliverable that you have seen, but you can extract what exactly you want to extract. And it's very important, if I repeat today or after, because after 3 years, I repeat the scan, it's possible to compare the two scans in different time to see the modification during the time, okay, during the years, the past of the years. So another case that I have measured underground is in Naples. This is the company of is ABC, okay. The ABC is the water company of Naples, and they have a big problem because this is one of the 8 depots that they have underground in under on big hill outside Naples, and are very, very big and impressive because they contain a lot of liters of water, and are very, very old, because I repeat to you, probably is the first water depot built in Italy. Of course, Roman people was the first that built water pipelines or water path, I know. But of course, this is the first modern water depot. Is around one during the king when the kings was in Naples in Italy around no, I don't remember exactly the age, but was very, very old and very, very important in terms of heritage and in terms of use of the city. So this is a big problem because it's running today, is working today exactly, and but is an ancient site. So this is a big problem in Italy that we have. Sometimes we use old stuff. Okay, the same. This is a short resume of the day of the survey. What was smaller, the project, and again, I have not used topographic target, topographic points, or whatever topographic method, but I have only used cloud to cloud method to merge station by station. This is the dimension of the empty depot, of course, because usually the water is until this line, so is filled until this line, and the door to access to the depot is here, and you only you can see only approaching from this door the depot, but usually is sometimes is filled. And this is the scanner. Again, I used a P-series. I love the P-series because it is a topographic method by dual axis compensator. For me is very, very important. It's very to be sure about the verticality of the point cloud for my mentality, of course. But I repeat this because today the new sensors, they not have a topographic Z level, but they have a dynamic Z level that not have the same precision, and probably you cannot have as a result a point cloud not leveled. Okay. This is again a view about the reflectivity, and I spend 2 words, or you can spend 2 words if you want, to view exactly the wet and the dry zone, and exactly where is the line where the water is when it's fill arrive, the level of the elevation of the water. And here is very clean where the areas here of the missing part of material, because when the water go down because they have emptied the depots, all these parts that are by pressure of the water are fixed on the wall. During the water go down, all the parts crush down. And we found it on the ground here, a lot of material, old material crushed on the ground, are very, very important to measure and to estimate how many new material we must buy to refill and to adjust the actual situation. Okay, this is very important. This was the final request of the customer, of course. Okay, two slides that you know very very good, I hope. And I want to spend 2 words again about reflectivity, because by reflectivity it's possible to see difference of color on the same surface. And if in this surface something is right by numbers, if you know here 700, that means that this is the line of 7 meters. So I have created a new UGS where my line, my blue line here, was put on the 7 meters. So the 0 is 7 meters down this line. So I fixed my 0. The UGS is user coordinate system. So I have changed my origin of the system 7 meters down this line to have all the elevation point that I pick on this point cloud correctly oriented. Okay, this is the cross section of the main entrance, and this is the main door, and this is a pipeline, and this is a valve and whatever. And from here start the stairs to go down 7 meters down, and this is the water arriving from here and go out from there. Okay, so this is the full level, and they want to another request was to estimate the final value in terms of liter of the water, to estimate exactly the liter that they have, because they don't have idea, because they never have measured of this. And if you take a look here, if you can see this is a vertical shaft here. This is a vertical shaft to bring area, because here we are around 20 meters, around 15, 20 meters underground, okay? So this is a 20 meters shaft to bring area, and there is one more vertical shaft in this position. This is again a grayscale picture. In grayscale is a reflectivity map in grayscale, okay? And this is a simulation of the level of the water. The blue one here is the level of the water at quote 0. And you can measure every quote with the new UGS, okay? And you can measure everything. You can estimate everything. You can measure every stone, every bricks, every stairs, every curve. You can bring everything. Here, this is the position this is the top view of the depot, okay? Here there is a big step, so different level and different elevation of the ground from here to here, and then it's pretty flat until here. And I have do it a station at the end of the depot, because here there is an arc, a more tunnel arc that connects the similar depot that is here in this area, because this was number 7, I remember, and there are 6 more depots here in this direction, and I don't remember how many depots are in this direction. I don't remember it. Okay, but we are talking about the first depot that serve water for a big city like Naples. Okay, is very, very important site. Okay, so follow. This is the step that I talked to you, and you can measure exactly the gap on elevation, or you can exactly, and you can see here, this is all the material crashed down exactly when the water was out, and all the material crashed down, and you can see here. So one of the methods is to bring all the material and to measure the bringing material. Okay, are missing something, or but you don't know where exactly is. Second, you can measure by laser scanner, and of each missing part of material, you can have 3D coordinates, and you can have exactly the thickness and the area estimated. I think that is very important. Where is black here? Because there was remaining a small part of water, and this is okay. This is the at the end of the depot. If you remember, this is a small stair. The stair is not exactly stair, but are excavated on the stone. Okay, and this is an arc that connect. This is hole. Is a small tunnel, and this is the connection with the other part, with the other depot, similar twin depot. Okay, and you can measure everything. You can create a new cross section and whatever. And only for this I have created this scan, and because at the other part of the depot was the water, I have not received the permission to go with the scanner inside this tunnel to repeat one scan here to connect the two twins depots, because it was dangerous, okay, for myself. So this is the final 3D mesh. The 3D mesh have the first target is to estimate the volume. Volume is estimated by moving this horizontal flat plane here, the blue one, moving step by step from the ground 0 until the elevation 7 meters, and then the software estimates the volume plus and neon. This is very important. Because they want to know not only the elevation, how many liters are present during the elevation is 7 meters, but they want to measure exactly, okay, at 5.5 meters, how many liters we have, okay? So by the software, it's only, there is the possibility to move the flat plane at elevation 5.5, and then to repeat the estimation of the volume. And this is very, very powerful tools, okay? I remember the mesh is the triangular surface. The triangular is the triangle is the same, the based shape in geometry. And so the mesh is the first non-uniform and non-flat surface, okay? Is an atypical surface, but is very, very used in a digital management of point cloud. This is one of the shaft that I talked to you on the start, and around here now, because it was closed, the shaft was closed. The scanner was not able to scan inside the shaft, but from point cloud I don't remember, but here probably there is the point where the shaft start. So for me, it was not important, not the section of the shaft and not the dimension of the shaft, because it was enough only to have this one, and this one was measured until the top. And my my opportunity was to put the scanner exactly down the shaft here, and then the second point to have the position. After these 2 points, I have created an overlap map with Google Maps, okay? Before of this, of course, it's possible again to create the green path. In this case, is green, before was red. And using this green path, it's possible to create all the cross section in one click. And after this one click, it's possible to save in a 2D CAD or in a 2D PDF. Okay. Of course, from the mesh, it's possible to export a 3D PDF of the object. Of course, again, exactly the same slide before for the envelope of rounded surfaces. Exactly the same like the previous example. And this is the orientation in Google Earth. So in Google Earth, you can see the outside point where the vertical shaft bring area for the depot that is underground of this hill. This is a big hill. This is the main roads from that go to Naples. Okay, and this is the this vertical shaft, the start point, and this is the right point. I have measured in Google Earth the distance of these 2 points, and I have measured one. Okay, this is, if you can see, this is the point cloud. This is the circle of the point cloud that define the position of the second shaft. I measured the distance from this point to the first point of the shaft, and I have measured that was 114 meters. 140 meters was exactly in Google Earth. So I say, of course, the people on the site, they suggest me where was these points. Okay, but I have verified by measuring that the distance. And then I have create an overlap situation. Overlap situation is, of course, the depot is the part, the thickness part. I have created the black, transparent black flat plane for a graphical result. But the survey, the depot is only this one, you know. And the distance from the first shaft to the second shaft is 100 meters, so are missing, for example, until one more 40 meters until here. So probably the final distance was around 200 meters. 200 meters data. And from the left side here, there are more 6 depots, similar, probably 3 exactly with the same length, and 3 more little bit shorter. But this is the big result. Was a big project, was a big presentation, and the customer was very happy because they have understand the capability of the laser scanner to produce what they want. But you know, the laser scanner don't produce what they want. The laser scanner produce a point cloud, and there are you that can extract what you want from the point cloud. This is my final message, and I don't know if I was long on or short, but I thank you for your attention, and I have end my presentation. If you have, of course, questions or whatever, you can, of course, ask to me everything. Okay, Cornelius, if you want to say something.
Yeah.
Yeah.
Thank you very much for the very interesting presentation. It is for me a very great pleasure again to see it all and have it